The topic is related to the integration. We will learn how to integrate by parts. We are already aware of the product rule of differentiation. Integrating the product rule leads to the method of integration by parts. We will get help from the product rule of differentiation. This method is an important method of integration which is known as integration by parts. The method parallels that of substitution with the chain rule replaced by the product rule. In the substitution method, we use the chain rule, while in this way integrating we will implement the product rule. The product rule for the derivative is mentioned here. This is the product rule. If we have two functions which are in the product form, we will differentiate and we will obtain two terms with this positive sign in between them, while this is the derivative of first term, second term as it is. Here first term as it is, the derivative of the second term is mentioned there. This is the product rule for differentiation. Since fx dx, this product is the antiderivative of this, because this is the derivative of this product. Therefore, this is the antiderivative of this sum. We can write it as an integrand, this term, and integrating this we will definitely obtain this plus constant of integration. Now we are going to develop a method of integration by parts. Let's see further. If we apply the sum rule and transposing one term leads to the formula. This integral sign plus this integral sign, and here this is this part, while we have shifted this part to the right hand side here, and this term is already available here. The constant of integration is again. We have used the product rule of differentiation and then integrating both sides using the rule of sum, and then shifting one term on the right hand side. We obtained this whole relation. We can use this for integrating by parts. If the integral on the right hand side can be evaluated, it will have its own constancy, so it need not be repeated. We thus write it in final form. This is the method to integrate by parts. We want to apply this formula. We need to break up a given integrand as a product of fx and g dash. If we will succeed to break it up as in two terms as a product of fx and g dash x, then we can easily apply this formula. Sometimes we have to face that integrands will involve trigonometric, logarithmic, or exponential function are often good candidates for integration by parts. Sometimes these help us to integrate by parts, but practice is necessary to learn the best way to break up an integrand as a product. This is the first example. The integrand is the product of two terms, while first term is x and the second is cos x. And we have to integrate this product by using the integration by parts rule. We know that cos x is the derivative of sin x. And we need to break this product in such type of functions. We want a function fx and g dash x. We can say fx is equal to x, this is fx, while gx is equal to sine of x. If gx is equal to sine of x, then what is g dash of x? The second part is g dash of x. This is the fx and this is the g dash x, derivative of gx. Now using formula, we will write it as minus derivative of x sin x, which will be later on. After simplifying, we obtain this result. This is gained by using the formula. And finally, we obtain this answer. Now we want to verify that the obtained result is true or not. We can differentiate this with respect to x. And if we differentiate this with respect to x, we obtain x as it is, derivative of sin x plus sin x as it is, and derivative of x, which is equal to 1 minus plus derivative of cos x, which is minus sin x. And simply after simplification, we obtain this value, and this is the integrand which was given to find the integral.